Okay, that seems weird with me seeing myself in the background. Does that look clear? That kind of hurts my eyes. That's okay? It looks a little fuzzy, doesn't it? Maybe it's me. I do have trifocals. All right. So this is the first example, 147, number 1. Factor this mess. So what we're going to do is we're going to start by saying, let x equal x minus 1. Now, you purists out there might have an issue with this because x and x minus 1. So I'm going to change it to y, just because how does x equal x minus something? So let's say y equals x minus 1, and we're going to say 3y squared plus 25y plus 8. Not funny. Does that make sense? And I'm sure you guys are pretty comfortable with factoring and stuff now, but I'm going to keep going just to let you know what we do when we get to that. So everywhere there's an x minus 1, we put a y. This x minus 1 is squared, so this y is squared. This is just x minus 1, so this is just y. 3 times 8 is 24. We have 2 positive signs, so the numbers are going to add up. 2 factors of 24 that add up to 25. I'm going to go with 24 times 1. 24 plus 1. Now, 24 has factors with 3 and with 8. So I don't really know where to put it. So I'm just going to put it in the front part, or I'm going to put it in the back. So we have 3y squared plus y plus 24y plus 8. So we take 3y out. So that's y plus, I can't take 3y. Take y out. So it's times 3y plus 1. And then out of here, I'm taking 8. And then it works out 3y plus 1. Sorry for this mess. This is just y. That's all I took out of this. So it's y times 3y plus 1 and 8 times 3y plus 1. Because 8 times 3 is 24. 8 times 1 is 8. Which means y plus 8 times 3y plus 1 is the factored version of this. But remember, if I could have that sound every time I said remember. So everywhere there's a y, I'm going to put in x minus 1. So this equals x minus 1 plus 8. For somebody with ADD, this is going to be hard. Put the x minus 1 in the brackets. Now I'm going to resolve those brackets. Should I ask if they can turn it up? I have no idea what's going on with that. I think the Bible, to be honest with you. Okay, so let's resolve these brackets. Nothing is multiplying this x minus 1, so I can just drop the brackets. X minus 1 plus 8, and I'm doing every single step. I want to recommend being careful when you skip steps, because you're in high level math. You do every single step, you'll be here forever. Just be careful, be neat, be organized. So now this one, 3, I have to multiply this 3 through, so it's 3x minus 3 plus 1. And then the final step, x plus 7 times 3x minus 2. Yep, it is. The next example I'll skip a little bit just to get finished before sun sets. What was I going to say? So this right here, if you multiply this through, it would equal the exact same thing as this if you multiplied it through. Okay, x minus 1 times x minus 1, then you multiply all that by 3, 25 times this plus 8, get all the common terms, collect like terms, and you'll get the same thing as you would when you multiply this. Questions? The trick is seeing past the mess, because everything you do is everything the same. It's just seeing past that initial mess. Anybody still writing? Is this recording? Yes, okay, good. No one's still writing? Something I used to offer, I just haven't in a while. Does anybody want this? You guys all got a copy, right? Okay. It's good that you have it copied. I think this is more when I was doing grade 8 math and people wanted it in my writing or whatever. I seem to remember Richie always fighting for it. Numero 20 from page, where are we, 147? Okay, so now we have 2 times x plus 3 squared minus 15 times x plus 3 plus 28. Also, you can also, well, I'll show you what I was going to say in a second. So I'm going to say, do you want to use a different letter instead of y, just to give you some experience? Because it's not always going to be x's and y's. Let's say n. N is a popular math. So popular math substitution. So n equals x plus 3. So 2 times n squared minus 15n plus 28. I noticed the 2 and the 28 that jumped out at me, so I thought, oh, I need to factor out a 2. You can always look to find a greatest common factor. If we can simplify this, in this case, it doesn't work. Has to be even because there's a 2, and a 15 is not even. So 2 times 28 is 56. Now, if you remember, a negative and a positive means both signs in the brackets will be negative when you factor. And so the factors of 56 will both be negative and add up to negative 15. So if I say, for example, off the top of my head, negative 7 times negative 8, that equals positive 56. And negative 7 plus negative 8 equals negative 15. So that's what we're going with. 7 and 8, I'll put the 7 on this side, the 8 on this side. So we have 2n squared minus 8n minus 7n plus 28. I should use a different color for that. Anyway, equals, now I'm going to do some factoring, 2n, it's going to be n minus 4. Now, I'm going to, maybe don't write this down, what I'm going to write down now. Like you can write this down, but I'm going to do something kind of wrong just to show you how to get your way out of it. If I do plus, and I take out 7, plus 7, it'll be negative n plus 4. Now notice that n minus 4 and negative n plus 4, these are not the same thing. Which means if you do this and you go, oh crap, all it means you need to make that 7 negative. So instead of saying plus 7, minus 7, and then it's n minus 4. And you guys probably know this because of all the examples you've done already, so maybe I didn't even need to go through that. So it's 2n minus 7 times n minus 4. Now, we need to put in x plus 3 everywhere there's an n. 2 times x plus 3 minus 7. And here I don't need to use brackets. So it's x plus 3 minus 4. Simplify 2x plus 6 minus 7 times x minus 1. 2x minus 1 times x minus 1. Cool. Any problems? When I have my head down, Evan, every time I see your leg move, I'm not complaining. I'm just saying I keep thinking somebody's walking in the room and look up, no, look up, no, look up. Last semester teaching Gavin, his hair was lots longer. I noticed he got a haircut recently. anytime, if I had my head down, anytime he'd run his fingers through his hair, I thought his hand was going up. And the class was so small, I would instantly, before I would kind of do anything, I would think, just say my name, Gavin. Don't put up your hand. Like, it's a waste of time. He's not even putting up his hand, he's just fixing his hair. I can't tell you how many times that happened. Does everybody have this? We're all good? Any questions? Aaliyah, you writing still, sister? You good? Kayla? You good? Everybody's good? Success? You just entered the assignment? Okay, cool, cool, cool. As soon as, you know, if you think, oh, I got this is easy, then, you know, knock yourself out. You can start with the assignment, but I'll do the examples just in case, unless nobody wants me to. Anybody want an example still? Okay, good enough. I just need one. Number one, page 149. So this is from like 5.5. Difference of squares. So the first one is n squared times x minus 3 squared minus m squared times 2x plus 5 squared. Now here, if you want to kind of skip some steps and make it a little quicker, I'll show you the skipped step form, and if you don't like that, then we don't have to do it. But if we're going to bypass the part where we say let y equal x minus 3, oh, what the, oh yeah, it doesn't matter. See, now notice we have two different things. So I'd have to say let y equal x minus 3 and let p equals 2x plus 5 or whatever. It gets a little bit more complicated, but we see that these are squares, right? So I can just write in the first one, n times x minus 3 plus m times 2x plus 5. And then n times x minus 3 minus m times 2x plus 5. Just makes it way easier. I should, way easier, way quicker. The substitution would take extra time. If you can see it, because all we're doing is having, H-A-L-V-I-N-G, having these exponents. If these were 4s, then they would be 2s over here, and so on. And now I just reconcile the brackets. N times x minus 3 is nx minus 3n plus 2mx plus 5m. I can hear some of you thinking, when will I ever need this? Nx minus 3n minus 2mx minus 5m. And now you collect like terms in the brackets. And there aren't any. Nx, n, m, x, m. Yeah, that's it. Isn't that pretty? This is one of those questions where if you're like me at all, you get this answer on a test and you're like, I did something wrong because this is way too ugly. Sometimes it's just ugly, and that's okay. See, we have the exact same thing here in each of the brackets. It's just we've halved the exponents. We put a plus and a minus. Is it okay me showing you this way of doing it? I think it'll be a little bit trickier. Well, it's up to you. If anybody wants me to do the longer way for 2, I can do the longer way. I can do both ways, whatever helps. Who wants the longer way? Don't be ashamed, afraid. Nobody? If you do, yeah, you do. Okay, thank you. Because you're speaking for more than one person. It's always more than one person that wants it. So number 2, the question is 25 times x plus 4 squared minus 64 times 2x minus 3 squared. I'll say let x plus 4 equal p, and we'll let 2x minus 3 equal q. So we rewrite this as 25 p squared minus 64 q squared. We factor. The root of 25 is 5. The root of p squared is p. Minus the root of 64 is 8. The root of q squared is q. That's one side. The other side is 5p plus 8q. And then we bring these monsters over. Am I going too fast? Okay. Yep, for sure. I was thinking about that. So now anywhere there's a p, I'm going to put x plus 4. So 5 times x plus 4 minus 8 times anywhere there's a q, I'm doing 2x minus 3.
Can't really see.
Will you stop complaining? Thank you for letting me know. 8 times 2x minus 3. So that's the first set of brackets. Second set of brackets, 5 times x plus 4 plus 8 times 2x minus 3. What a mess, hey? And now we have to simplify. We have to resolve those brackets. That's not how you say it. 5 times x is 5x. 5 times 4 is 20. 8 times 2 is 16. Negative 8 times negative 3 is positive 24. One set of brackets. Same over here. 5x plus 20 plus 16x minus 24. Now we collect like terms. We have single x's and constants, so this will be much smaller and cleaner. 5x minus 16x is negative 11x. 20 plus 24 is 44. 5x plus 16x is 21x. 20 minus 24 is negative 4. It looks weird. You have that negative in front. I hate the way that looks. I want to change that. But it's fine. It's totally correct. And if that really bothers you, you could write the final answer like this. You just pull a negative out of this set of brackets. Pull a negative out, so it becomes 11x minus 44, right? Because all the signs inside change. 21x minus 4. You don't need to do this, but you can if this makes you feel better and will help you sleep at night. Questions about that? Okay, I'll do short version. If you've seen enough and you want to get to the assignment, knock yourself out. Not literally. Okay, that was 25 times x plus 4 squared minus 64 times 2x minus 3 squared. Okay, so the short version, the root of 25 is 5 times x plus 4 minus the root of 64 is 8 times 2x minus 3. That's one set of brackets. You don't have to do the squares. I do things inconsistently. And then again, you do this whole exact same thing except with a plus. 5 times x plus 4. What am I doing? Plus 4, sorry about that. 5 times x plus 4 plus 8 times 2x minus 3. And then you simplify, resolve the brackets and all that good stuff. So it's 5 times x, 5x plus 20 minus 16x plus 20. 4 times 5x plus 20 plus 16x minus 24. Sorry, am I going too fast? It just was. And then you collect like terms. So it saves you, you guys can't see this, I'll show it in a second. It saves a bit of writing. See, this is the other way. So it is a little bit quicker. If you see it, if you don't see it and you need to take the long road, no problem. There is zero harm in that. That's all I got for you. Class is yours. If you have questions, please do not hesitate to say so. I'm going to end this Zoom meeting just so I can post the stuff for Ada. Is anybody still writing this? Oh, even if you are, I can leave the screen up. I just need to end it.